Welcome back to the International Scientists and Philosophers Banquet. I'm your host, John Scrocco, and we have just gotten word of the winner of the Advancing Science and Learning. But first, let's take a look at the nominees.
Danish nobleman Tycho Brahe, French mathematician and philosopher René Descartes, English mathematician and physicist Isaac Newton, and German astronomer Johannes Kepler.
And the winner is Johannes Kepler.
Johannes Kepler was born on December 27, 1571, in Weierstadt, a city of the Holy Roman Empire of German nationality. He was a sickly child and his parents were poor. His hands were crippled and his eyesight permanently impaired by smallpox. Despite these difficulties, many were astonished at his ability to solve any problem involving numbers. His intelligence earned him a scholarship at the University of Tübingen to study for the Lutheran ministry. There he was introduced to the ideas of Copernicus and delighted in them. He was one of the few students deemed intellectually and mathematically capable of being taught the works of Nicholas Copernicus. In 1596, while a mathematics teacher in Graz, Austria, he wrote the first outspoken defense of the Copernican system, the Mysterium Cosmographium. The book summarized a relationship among the 5 regular Platonic solids and the 6 planets known at the time: Mercury, Venus, Earth, Mars, Jupiter, and Saturn. In simple English, it included what Kepler thought God's geometrical plan was for the universe. Kepler left Graz to move to Prague in 1600 to work under the supervision of great Danish astronomer Tycho Brahe due to the Counter-Reformation. In 1609, after the death of Brahe, Kepler published Astronoma Nova, which contains his first 2 laws of planetary motion. The law of ellipses, Kepler's first law, is rather simple. All planets orbit the Sun in a path that resembles an ellipse, with the Sun being located at one of the foci of that ellipse. Kepler's second law, sometimes referred to as the law of equal areas, describes the speed at which any given planet will move while orbiting the Sun. In plain terms, it means a planet moves fastest when it is closest to the Sun and slowest when it is farthest from the Sun. In 1619, he published Harmonies Mundi, in which he describes his third law. Kepler's third law, sometimes referred to as the law of harmonies, compares the orbital period and radius of orbit of a planet to those of other planets. In plain English, it provides an accurate description of the period and distance for a planet's orbit around the Sun. Kepler published his final and most influential work, Epitome Astronomae, in 1621. It was written in parallel with Harmonies Mundi, which discussed Kepler's law and all of heliocentric astronomy. Kepler died in Regensburg, a city in present-day Germany, in 1630 while on a journey from his home in Sagan to collect a debt. Kepler's laws have an important place in the history of astronomy, cosmology, and science in general. They marked a key step in the revolution which moved the center of the universe from the Earth to the Sun, and they laid the foundation for Newton a century later with his universal law of gravitation.